You know that screen on your e-reader? Ever stop to think about why it feels so different from your phone? It's calm, it's easy on the eyes, and the battery seems to last for an eternity. Well, today, we're going to peel back the layers on that seemingly simple surface to get into the really clever tech behind electronic paper.
Okay, so let's start with the one everybody knows, the Kindle. For years, these devices have pretty much been the gold standard for reading digitally. But the real magic isn't just about how many books it can hold, it's about the screen itself.
Seriously, think about it. Your phone or your tablet, that's a glowing rectangle, right? It can be a real pain to see in bright sunlight and it just devours your battery. This thing, it's the complete opposite. So what's the deal? What's the secret?
All right, first things first, let's break down what actually makes electronic paper so fundamentally different from every other screen you use every day.
Here's the core idea, the most important thing to get. Your phone's screen emits light. It's actively shooting light out into your eyes. Electronic paper does the total opposite. It reflects the light that's already in the room, just like a page in a physical book. It's not a light bulb, it's more like a really, really smart mirror.
And this one single difference gives it two huge advantages. First, because it's reflecting light, it's amazing to read in direct sunlight. In fact, the brighter the sun, the better it looks. And second, the power consumption is ridiculously low. It only uses energy when the image physically changes, not to just keep the words on the screen.
So how in the world does it perform this trick? Let's zoom in, way in, and take a look at the tiny mechanics that create this whole paper-like illusion.
Okay, so this is the basic structure of the most common kind of e-paper. Think of it like a sandwich. You've got a top and bottom layer, that's the bread, and in the middle you have the magic filling. Millions and millions of tiny little capsules filled with electronic ink. Now, inside each one of those microscopic bubbles, there's a clear fluid. And floating around in that fluid are two kinds of pigment particles. You've got white ones with a positive charge and black ones with a negative charge. They're like these tiny, two-sided pigment balls just swimming around in there.
So here's where it all comes together. When the bottom layer applies a negative electric field, it attracts all those positive white particles up to the top, making that spot, that pixel, look white to you. Then, apply a positive charge, and it pulls the negative black particles to the top, making the pixel look black. And that's it. That's how it draws letters and images.
You know, this whole concept was a massive breakthrough, pioneered by some researchers at MIT back in the late 90s. See, before they figured out how to lock the ink inside these little microcapsules, the tech was super fragile and really hard to make. This one innovation is what made durable, flexible e-paper a reality.
And right here, this is the answer to our battery life question. The image is bistable. What that means is, once those little black and white particles are in position, they just stay there. No electricity needed to hold them in place. The screen only sips power when you turn the page and the particles have to move. The rest of the time, it's just coasting, using zero power. Incredible.
So that's the theory, but here's what it actually looks like in the real world. This is a macro shot of a Kindle screen. If you look really close, you can see that slightly grainy texture. That's what you're seeing, millions of individual microcapsules, each one acting as a single tiny pixel.
Now, while e-readers are obviously the most famous use for this stuff, this technology is actually hiding in plain sight in all sorts of places you might not expect. For instance, public transit timetables. This sign from Prague is a perfect use case for e-paper. It has to be readable in bright daylight, and because it runs on almost no power, it can be updated wirelessly without needing some complex, expensive electrical hookup. It just works.
Or how about this? This is just clever. It's a USB drive with a tiny e-paper screen that shows you how much storage is left. Because the display is bistable, it holds that image even with zero power. You can just toss this in a drawer, pull it out a year later, and you'll still know exactly how much space is on it without ever plugging it in.
The tech even made its way into cell phones, like this old Motorola F3. The point wasn't to have fancy graphics or video. It was all about creating a super rugged, simple phone with a phenomenal battery life and a screen that was always easy to read. And the list just keeps on growing. You'll find e-paper in grocery stores as electronic price tags that can be updated instantly, on early smartwatches like the Pebble, in all kinds of digital signs, and even embedded right into smart cards for extra security.
So what's next for this super versatile technology? Well, the journey to perfectly replicate paper isn't quite over yet, and researchers are hard at work tackling its biggest limitations.
The big frontiers right now are color, speed, and resolution. Companies like e-ink are constantly making color displays more vibrant and affordable. That slow refresh rate is another hurdle, but researchers, like a team at Uppsala University, are now developing displays that can actually handle smooth video. And they're even working on what you could call Retina e-paper, a resolution so sharp it's indistinguishable from print.
Which, it leaves us with a pretty fascinating final thought. For decades, we've been trying to make our digital screens behave more like paper, to be easy to read, super energy efficient, and portable. As we get closer and closer to that goal, what does that mean for the original? It really makes you wonder about the future of the page, both the ones on our screens and the ones in our hands.